Algebra 2, section 7.4, we're dealing with solving log equations. Now, for this one, the property of equality for log functions is log b of x equals log b of y. So just like when we're dealing with exponential functions, if the base is the same, then their exponents are the same. For this one, if the log base is the same, then the number they're logging is the same. So if log of 5 of x equals log of 5 of 8, then x has to equal 8 in order for them to be the same. So strategy is very similar to that of exponents. Okay. So when it comes to inequalities, it's very similar. Also, you have log b base of x is greater than y, and x is greater than b to the y. You can rewrite it like this, but if it's log b of x is less than y, then when you rewrite it, you have to make sure that x is between these two values. If b is greater than 1, b has to be greater than 1. In order for these to be true, b has to be greater than 1. This one just has a y on one side. This one is 2 logs. So b has to be, as long as b is greater than 1, then x and y, then we can just focus on the x and y, and we can focus on the x and y here, whether it's greater than or less than. So they're asking me to solve log 8 of x. So when we solve number 1, we have to use a combination of what we learned in this section, but also what we learned in last section on rewriting it so that we can solve it. So number 1, if you remember, this is the same thing as when we did log b of x equals y, and then we can convert it to be x equals b of y, right? So from this, I have to just locate b, x, and y. My b equals 8, my x equals x, and my y equals 4/3. So I'm going to rewrite it like this. X equals 8 to the 4/3. Write it all. So now we just have to solve for 8 to the 4/3, which is basically the cube, square root of, the cube root of 8 to the 4th. But what I'm going to do is, because it's the same as the cube root of 8 to the power of 4, the cube root of 8 is 2 to the power of 4, and 2 to the power of 4 should be 32, right? 16. My bad. And so our answer is 16. That's actually more a review of last week than it is of the new section, but please make sure that you remember this conversion. It's very similar to that of the inequality, if you see. So go ahead and pause and write this down. And then I have one more board of example problems. So this one says to solve log 4 of x squared and log 4. So because of the rule that we learned here, because the log base is the same, so log of 4, then we know that x squared has to equal negative 6x minus 8. Okay? And if this is the case, then I'm going to bring everything, whenever I have an x squared, remember I have to solve it like a quadratic equation. So I'm going to bring everything to the other side. I'm going to plus 6x, and then plus 8. So I end up with x squared plus 6x plus 8 equals 0. And with this I have, because there's no number in front of the x, makes it easy. 2 numbers when multiplied together gets me 8, but when added together gets me 6. So I have 4 plus 4 plus 6. Sorry, no. Plus 4 plus 2. Now, I factored it, but I have to actually solve it. So I have to do x plus 4 equals 0, because if this equals 0, the whole thing equals 0, and if this equals 0, the whole thing equals 0. So minus 4. So my first x is negative 4, and then x plus 2 equals 0 minus 2, x equals negative 2. So this should all just be review. It's just making sure that you have the same base here. So on number 3, when we're dealing with inequalities, we have to do the same thing as last time, so we have to find the range. Now, so in this case, the rule is that in order for this to work, b has to be greater than 1, which is true because we have log of 7. But also, it says that these values have to be bigger than 0. So they can't be negative numbers. I can't log base anything with regular numbers. With negative numbers. So I have to know, and these are not correct, so please bear with me, because I think I used the wrong equation. So I have to know when 2x plus 8, right, is equal to 0. It has to be bigger than 0. And I have to know when x plus 5 is bigger than 0. And then I can solve it like I regularly would, which is right here, when I just do 2x plus 8 is bigger than x plus 5. So my answer has to hold true for all of these equations. So let's solve. Remember, I'm solving just like regularly, except when I add and subtract by a negative number, I have to flip, not add, subtract. When I multiply or divide by a regular number, I have to switch the sign. So I'm going to subtract 8. Then I have 2x is greater than negative 8. Divide by 2. I end up with x is greater than negative 4. The next one I subtract by 5. I end up with x is greater than negative 5. So this one, I'm going to bring x, I'm going to minus x on this side. I have x plus 8. This cancels out, is greater than 5. Minus 8 on both sides. I end up with x is greater than negative 3. So, if you're a visual person, which I am, I would do a timeline so that I can make sure I have all of the requirements. So here's 0, negative 4, negative 5, negative 3. 3, 4, 5. Okay. So I know that negative 4, that x has to be bigger than negative 4. X also has to be bigger than negative 5. So no matter what, and then x has to be bigger than negative 3. So because none of them are facing the other way, there's no restrictions, I know that this, if I make x bigger than negative 3, it satisfies all 3 equations. So my answer is x has to be greater than negative 3. And because this doesn't include negative 3, this also cannot include negative 3. Now again, you might ask, what's the point of having all 3 of these? Because sometimes the arrows are facing different ways. Sometimes there's different type of requirements. I need to see where all of the requirements overlap, and those are the only answers that's available to put in here, because there's a requirements for inequalities. So hopefully that makes sense. Go ahead and pause and write this down. Try page 480, numbers 1, 3, and 6. 480, numbers 1, 3, and 6, and I will see you in class.